Hello friends, my name is Habib. Today we are going to learn how to create a basic platformer game. How to create a full platformer game in Godot. So first, you have to open up Godot, and before you watch this video, make sure that you have watched my introduction to Godot video. So anyways, first you have to open up Godot, new project, plat. Now click on browse, go to documents, create folder, name it plat. Create folder, name it farmer. Select current folder, and the folder that you put your project in has to be empty. Compatibility. What compatibility means is that forward plus means that the game you make, if you choose forward plus, that means your game is for high-end devices. Mobile means your game is for mobile, and compatibility is just going to make your game to be compatible with whatever hardware you're using. Since we don't want it to make this game for mobile, and we also don't want to since we don't have a high-end PC and we don't want to make this game for mobile, I'm going to choose compatibility, since it's the best for low-end devices. Create and edit. Now we have this scene here, I guess. So anyways, if you want to do something basic in this scene, if you want to create a basic level, click on 2D scene, add a new node, let me delete this node. Now you can choose either of these. If you choose this one, then that means you're creating a 2D scene or a level. If you choose this one, then that means you're creating a 3D scene or a 3D level. If you choose this one, then that means you're creating user interface. Still going to create a 2D scene. Click on here. Now this is going to create a 2D scene. And this can also be used as a level for, creating levels. Now our platformer game is going to have only one level. So anyways, now that we've done this, I'm going to save this, and scenes, they can be anything. The player character, they can be levels, they can be the enemy, they can be collectibles, they can be text, they can be anything. Scenes are like objects in your game. Now create a new scene and choose character body 2D. Character body 2D is for creating something interactive, or like something that can move, like character body 2D. It's for creating something interactive, like you can use character body 2D to create enemies, you can use it to create the player, you can use it to create the score counter, etc. Now name the scene player, since this is for the player. Now under the character body 2D, click on this plus sign. Yes. No. Now search for image 2D. Wait, no. Now open up your drawing program. For me, I'm going to open up Xscape. New document. Now open up the drawing program you're comfortable with. Then start creating a player character. I'm going to make my player character a rounded square. I'm also going to give it, what do I do? I'm also going to give it outline. I'm going to make my player character a green square. So I'm going to give it outline. and then I'm going to export it. Now, once you've done creating your graphics, once you've done creating your player character, export it. Go to where your now go to where your platformer is located. Farmer. Now in it, create a new folder, naming it images img, and this folder is going to be where all the images stored. And name your image player.png. Save. If I open up Godot, you'll see that now I have the player sprite. This is the player sprite, the sprite for the player. It must have been a mistake. Selection. Let me re-export it. Save. Place. So anyways, now you have your player sky. Delete this, do this. There you go. Now you have your player. Save. So anyways, once you have your player, you can make it down. You can, make it smaller. And this tool is for moving an object. This is tools for rotating the object. This one is for scaling it. I'm going to make this player smaller. So hold shift and then scale it and make it small until this is good enough. And now I'm going to move it to the center. If you're wondering what this, now you might have been noticing this small thing here. This dot. If you're wondering what this dot is the center of rotation. The player is going to rotate from this dot. So now you have to make the player to be at the middle of this dot. Select the player scene, drag it. Now the player scene is in the middle of the dot, so that means it's going to always be rotating from the middle. Now you can drag the player scene here, and then click on here, which is going to play the scene. And now it is going to play it. So anyways, but you see that the player is just standing there doing nothing. So to remedy this, I'm going to create a collision shape 2D. This collision shape 2D, it allows the player to interact with anything in the scene. So without this, the player won't be able to interact with anything. I'm going to make it a square, and make the square to be roughly the same size as your player. And then create a new script. A script is the functionality of an object, the thing that allows an object to do things. Now you see this template. Well, if you want to quickly create a basic platformer character, then you can click on this template. But we want to create a platformer from scratch, so no template for us. I can also choose the path. This path is fine, so I'm going to click on create. So now it creates the scene. Now you see this extend character body 2D. We're just going to leave it, but this is very important. If you delete it, then it's the thing, the script is not going to work anymore. I'm going to create a func_physics process. Anything inside of this physics process is going to be running every single frame. So like if you make the character to move right in this physics process, then it's going to be moving right every single frame. And this delta It is used for smooth or constant motion. So, what if we want to make our player fall down? You have to write velocity.y plus equals 50. Now, if we run the scene, you will see that, yeah, the player doesn't do anything. Why? Well, that is because if we want to, because there are two variables, velocity.x and velocity.y. If we want to use any of these variables, we have to write move and slide, which will allow us to move the player. This function allows us to move the player. Now you will see that the player can fall down. Now, what this velocity.y does, this velocity.y is the speed of the player on the y-axis, while velocity.x is the speed of the player on the x-axis. What this does is that it increases the speed of the player on the y-axis every single frame. Now, if you want to make it smoother, then we can write times delta, but we don't really want to do that. So anyways, now that we have this, we actually need a ground for the player to, stand on. So now create a static body 2D. A static body 2D is something that doesn't move. And also, you can put nodes inside of nodes in Godot. Static body 2D, it doesn't move. It just stays stagnant like that, staring at you. Now I can create a polygon 2D. A polygon 2D, it allows you to draw, it allows you to draw with points. Now, it's polygon 2D. No, wait. Now I can draw with it. Draw. Let me draw a basic level here. Now I have drawn a basic level. You can also edit the points afterward. It's really convenient if you just want to make a quick character, or if you want to make complex shapes. And there's also a collision polygon 2D. No collision shape. The collision polygon. What collision polygon 2D actually does is that it allows the thing to interact with other things. So this static body 2D, it cannot interact with anything unless it either has a collision shape or collision polygon. Collision polygon, the advantages of it is that collision polygon allows you to create collision boxes for complex shapes, like this level here. But the disadvantage is that it's not as quick as easy as using collision shapes. So if you have a complex shape, then it's better to use collision polygons, and if you have a simple shape, then use collision shapes. Now you see that the player can fall onto the ground. See, the player can fall onto the ground. But there's a problem. The player cannot move. And also, you have to make the collision polygon 2D to be the same shape as the thing that, as the thing that you want to be able to make to be able to interact with other things. It has to be the same shape. So this collision polygon 2D has to be the same shape as this level. Otherwise, if we make it a different shape, let me just make this to be a different shape. If we don't make it the same shape, then if we don't make it to be the same shape, then you will see that the collisions are all messed up. It doesn't interact with it properly. But currently the player cannot really currently the player cannot really move. If we press anything, nothing happens. So because of that, we have to create an input, as I call it. Go to project settings, go to input map, and then here we have to add a new action. And then for this action, it is going to allow the player to move right. So click on right and then press enter. This action allowed the player to move left, and this action allowed the player to jump. Now we're basically going to be creating a Mario clone, since we don't want to create anything complex. Now click on this right action, click on this plus button, and then click on the right arrow key. Click on this left action, click on this plus button, and then click on the left arrow key. Okay. Jump. Click on this plus button and then click on this space arrow key. What this does is that it basically maps these inputs to the action. So if we define these actions, if we mention these actions in our code, then these inputs are related to the action. Now this right action is basically the right arrow key, this left action is the left arrow key, while this jump action is the space key. You can also add multiple inputs to one action. So I can click on here. If I want the player to be able to jump with the space button and the Z button, I can just click on this plus button, then click on Z. Now the player can jump with either the space button or the Z button. Now let's close this and go to the script. Now I'm going to write if then inputs dot is underscore action underscore pressed right, which is the right arrow key, velocity dot x equals 400. Now if you press right, then the player will move right. But there's an easier way to do this. In the physics process, I'm going to create a variable. Variables allow you to store data. Now this variable, it will allow me to store data. So we're going to write var dir, which stands for direction, equals input dot get underscore axis left comma right. What this does is that this variable, it stores this and this. So if we press the left arrow key, then it's going to be -1. If you press the right arrow key, it will be 1. And if we don't press anything, then this will be 0. Since this is the left arrow key and this is the right arrow key. See, left, right. So now I could just write if dir, which basically means if dir is not 0, velocity.x equals dir times 400. So what this means is that if this is not equal to 0, then the speed on the x-axis is going to be equal to 400 times dir. And dir can either be -1, 1, or 0. If you play this, you can see that you can move left and right. But there's a problem. If we move left or right, then we're just going to continue moving and we'll never stop. So I have to write else, which means else, if this is not true, that velocity.x, I can just simply write velocity.x equals 0, which is going to set the player speed on the x-axis to 0. Now you see that we can move left and right. Oh, and also, if you want to make the player accelerate, then you can just write plus equals, which means this is going to increase the player speed on the x-axis by 400 times dir. I'm just going to change this to 50. Now we can move. But when we release the keys, when we start moving, it's just so sudden. It doesn't feel smooth. So we're going to have to write lerp f velocity.x, 0, 0.08. What lerp f does is that this value is the initial value. This value, first it takes in the beginning value, and then this is the end value. So what lerp f does, it basically transitions. It transitions from the beginning value to the end value. So if I write 10, so this lerp f is going to transition from 10 to 0, and this number, it is the smoothest of the transition. The more higher it is, the less smooth it will be, and the lower it is, the more smooth it will be. Since I want it to transition from the current velocity dot x, from the current x speed, which is velocity dot x, to 0, I'm just going to write velocity dot x. Now you see that we can move, and when we stop, it is the smooth stopping, not just sudden stop. Different types of stops: smooth stop, sudden stop. But the player accelerates a little too fast, so I'm going to write times 10 instead. Now he accelerates too slow. Ugh, what is this? I'm going to try times 33. Just write 35. There we go. Just perfect. Now, yeah, we have this player that could do all these stuff. What the player accelerates, he can accelerate. When he accelerates, the longer we keep holding right or left, then the faster he will be. So the player can reach extremely fast speed. So the player can actually reach infinite speed. The player can be infinitely fast if we just keep holding right or left. And we want the player's speed to have a limit, so we have to write velocity.x equals clamp f minus 1000, or minus, let's say 600, 600, velocity.x, minus 600, 600. What clamp f does, it limits the value here is what this clamp f will limit. So since we wanted to limit the x speed, which is velocity.x, I just put this so that it will limit it. And this is the minimum value it can be, and this is the maximum value it can be. So now you see that the player, it cannot just go extremely fast like he used to go. Instead, it has a limit to how fast it can go. Anyways, now we want to make the player jump. We've worked on all the movement, but now we want to make the player to be able to jump. So write inputs.is_action_pressed jump velocity.y equals minus 600. Now you see that if we press the space key, which is the jump key, then the player can fly. But we want the player to be able to jump, not fly. The reason why this is happening is because input.is_action_pressed. This means that if the action is pressed or held, then it will register it. So if the jump key is pressed or held, then this will register it. But input_action_just pressed. Let me remove this. What this does is that it only registers the input if the SIG is tapped, if the SIG is pressed, not if the SIG is held. So you see that we've now created a Flappy Bird clone. Flappy Bird clone, not really cool since it's just a Flappy Bird clone. I will change this to minus 900. What a high value. Yes, they've got a moderate jump, but we could still fly like Flappy Bird. How is this possible? So now we have to write and is on floor. This checks that if the jump key is pressed and the player is on the floor, then it is going to work. Now you see that we can't fly like Flappy Bird anymore. How sad. Not really sad since we don't want to create a Flappy Bird clone. What? So anyways, now that we've done this, we have to actually create the enemy. All this code we've been doing is for the player, but about the enemy. Now go into your designing software. Let me create a new file. Close. And now create an enemy sprite. Now I'm just going to copy the player sprite, and then I'm just going to copy the player sprite, and then change its colors. Create an enemy. And then I'm going to export this. Export, where is it? Export. And then go into the folder where you know there's a game is located, farmer, image. Then go into the img folder where all the images are stored. Enemy. Save. And now we have the enemy sprite in the folder. Yay! Yay! No, player sprite, stop it. What did I ever do to you? Sad. What did I ever do to you? You betraying me. Now you have to create a new enemy scene, character body 2D, since we want this to be dynamic, and name it enemy. Now drag the enemy image into the scene. Now make it smaller. Hold shift and then do this, drag to make it smaller. And this is the multi-purpose tool. This allows you to scale it and also allows you to move it, but it doesn't allow you to rotate it. So now hold shift, click on these circles, and then drag it down to make it smaller. Oh yeah, let me just grab this player seed for reference on how small the player is. Pretty small, so I'm going to make the enemy to be roughly the size of that. You can also press Ctrl plus or Ctrl minus to zoom in and zoom out. I'm going to make the enemy to be the same position as this thing, as the rotation point. I'm going to drag, going to select all of them and then drag them here. Where did the player go? Oh yeah, let me drag the player scene again. There you are, not a nasty dirty player. What were you doing there? Now I'm going to make the enemy to be roughly the same size as the player. No, delete the player sprite. I'm going to make the enemy to be roughly the same size as the player here. Let me drag this player sprite. Pretty small. To make the enemy as small as that. There we go. I'm going to delete the player sprite from here, the enemy scene. Control minus. I'm now going to drag the enemy scene into here. Now you'll see that with the enemy scene, we had the same problematic we had with the player scene. The enemy kind of just sits there, just floats there, looking at us. If you want to remedy that, then I don't know how long this video getting is. Pretty long. So if you want to remedy that, then you'll create a collision shape 2D. Let me just double click here to create a collision shape 2D. Zoom in a bunch. Then I'm going to create a rectangle shape 2D. And then make it to be roughly the same size of our enemy. I should probably stop saying roughly all the time. And now I'm going to create a new script for the enemy. This is fine, create. And then I can go to the player.gd script and then copy all of this and paste it. But except I'm going to remove anything related with controls. I'm going to remove this. I'm going to remove this. Remove this. Now all we have is the code for creating the gravity. Now you see that the player can fall. The player can fall like we want it to. But when we jump on the enemy, nothing happens. I mean, when we jump on the enemy, the enemy it's just staying there. So we could set its x speed to constant. Let's say 600. Now the enemy is very fast, but we don't want it to be very fast. It's pretty uncool. Now the enemy can move, but we want it so that when the enemy hits a wall, it is going to reverse its direction. So right, if is underscore on underscore wall, which means if the enemy is touching the wall, then velocity dot x times equals -1. Now when we do this, you can see when the enemy hits a wall, it just starts spazzing out like crazy. That is because the enemy hits the wall and then reverses. Because the enemy hits the wall, then reverses its direction, and then tries to go to the wall again immediately after. Which is not really what we want here. So create a variable called hit, which is set to false. This indicates when the enemy hits the wall. So if the enemy hits the wall, then hit is false. So I'm going to write if the enemy is on the wall and hit and not and exclamation hit. This exclamation hit means that this exclamation means not. This exclamation hit means that if the enemy is hitting the wall and hit is equal to false, then velocity dot x times equals -1. Now when the enemy hits the wall, it is going to set hits to true. So now if the enemy hits anything, it still starts buzzing out like crazy. Oh no, it doesn't do anything. What we can do here is that we can create a variable called speed, which is the speed, and set it to 400. I'm going to write velocity.x equals speed. So now, instead of doing this, we can write speed times equals 1. This speed is a variable, and variables can store information. If we run this, if the enemy hits the wall, then it's going to, go in reverse direction. I'm going to change my system so that hit is a variable and hit value is 0. So I'm going to increase the value of hit by 1 every single frame. So if the enemy is on the wall and the value of hit equals 0, this equals means equals to, so this means if the value of hit is equal to 0, and this and means that if the enemy is touching the wall and value of hit is 0, and the value of hit is not equal to 0, this is not equal to 0, then this happens. And then set the value of hit to 0 again. So it's buzzing out like crazy. Set the value of hit to 0, and the value of hit is greater than 2. Value of hit to 0. Please work. There we go. What this does is that it checks if the value if the value of hit is greater than 2, then it is going to do this. But if it's not, then it's not going to do it. Now we created a basic enemy whatever system. Now we need a way to dunk the enemy's head. Now we're going to make the player's movement to be constant, since it's pretty annoying, the player doing all this. Now we're going to create a few variables. We're going to create the speed variable, SPD, which is the speed of the player. We'll set it to be 600. And now we don't need this anymore since the player moves at constant speed. And then I'm going to create a variable for the jump height, which is equal to 900 minus 900 jump underscore height. And then I'm also going to create a variable for the gravity. GRV is short for gravity, which is going to be 50. GRV. Now you see that's roughly it's the same thing. Oh no, what's happening? Oh, why can't I? Oh, speed. I forgot to put their times speed. I thought the game engine, thought the game engine made the player to be moving right all the time. The player can't move left or else you get defeated. Very good player. But anyways, now we need to make it so that if the player donks the enemy's head, the enemy is going to. So how to do that? You have to create a new thing called an area 2D. Duplicate this and then put it in the area 2D. The area 2D, it allows the player to interact with things like collision shape 2D. But the area 2D allows us to define what actually happens when the player interacts with things. It allows us to actually define what happens when the interaction occurs. So what to name this area 2D? Player. Yeah, this area 2D, it allows us to define what happens when the interaction occurs. And this collision shape 2D, yeah, well, we have to put a collision shape 2D inside of the area so that it can actually interact with things. So now create an area 2D for the enemy, naming it enemy. Duplicate this collision shape 2D, then put it in the enemy thing, whatever it's called. And now, click on the enemy and click on node. Double click on area underscore enter to connect. Now, what this does is that if the enemy interacts with something, then we can define what happens when the interaction happens in here. You know that you've done this correctly when you see this sign next to the function. So now what it's so that if area was same is equal to player, which means that if the thing is equal to player, if the name of the thing is interacted with, is equal to player. Now area 2Ds can only interact with other area 2Ds. So what this does is that if the name of what the area 2D, if the name of what it interacted with is player, which is this, then it's going to say farewell q_free, it's basically going to delete it. q_free is going to delete it. Now if we jump on the enemy, let me try to jump on it. No, I have to jump on it. Then the enemy will get defeated. I'm going to disappear. I'm crying. But before it gets deleted, I would write area.get_parent. It gets the parent of it. Since these things, they're all children. These are all children to this. And these are all children to this. These are all children to this. And these are all children to this. Well, anyways, so area.getParent, which is going to get this. Dot velocity dot y equals minus 900. And, oh no! I have to run the node 2D scene, not the enemy scene. So now, if we defeat the enemy, no, what's happening? Why isn't the enemy getting defeated? Whatever, I'm just going to write now drag this player into here, $player dot velocity dot y equals minus 800. Now we're to drop on the enemy. Oh no, that's not what I wanted to happen. What's happening? Oh yeah. No. we have to set the collision shape to this of the enemy. We have to put it on top of the enemy seat. We want the player to be able to collide with the top of the enemy, not with the bottom of the, not with the entire enemy. No. I'm going to set this to a square shape, in a rectangle shape, whatever, to make this. I'm going to set this to the top of the enemy. I'm going to put this at the top of the enemy. Now save. Now you see that if we defeat the enemies, then we're going to have a slight, then it has a slight bounce to it. So now I'm getting bored of this simple level. There's not even a level. So we have to create a real level by using tile sets. No, tile maps. Tile maps allows us to create levels quickly and easily. It allows us to draw levels. So to define a tile map, we have to create a new tile set. So I'm going to create the level tiles. I'm going to create a simple rectangle. Oh wait, no. To create the level tiles, I'm going to create a simple rectangle. And then I'm going to change the color of it. I'm going to remove the stroke. And I'm just going to simply change the color of it to be delicate eerie. Let me see which color I'm going to use. Yeah, I'm just going to make the tile set to be gray. I'm going to make the tile sets to be light purple. Now I have to. Now I'm going to export this as tile. Now go to document. Now go to documents. Go to where image. And then exports the thing. Now that I've exported my tile image, shader editor's tile set. Now go to tile set, then drag the image into here. Click on yes. And now what this does is that this basically allows you to draw with it. You can select this by doing this. And now we could draw with the tiles. But the tiles are a bit big, so we can downscale it. Or shift, then downscale. Now the tiles are much smaller. Now we could draw with the tiles. Let me draw with the tiles. So yeah, now, but if we want to erase the tiles, then we could click on the selection, select this tile, and then erase it. Sadly. Now, I'm going to block out a simple level. Go to tile map, click on this pencil tool, and then select this tile. Now I'm going to block out a simple level. Now if you want to create a line, then hold shift to create a line. Now they're going to block out a very simple level. A shift, hold, line, shift, hold, line. Now you'll see that when we run this, save. So we'll run the scene. Why isn't this working? Oh yeah. The reason why this wasn't working is because this tile map, it was out of visibility of the camera. The camera couldn't see it. Now if you run this, you see that the player and the enemy, they just fall through the ground. Now this is the camera. Anything inside this will be visible, anything outside this won't be visible. Now you see the player and enemy just fall through it. Why? This tile map doesn't have any collision. Doesn't have any collision boxes to actually allow it to collide with other things. So go to layers. Tile map, paint, property, layers. Delete. Now click on this tile set, physics layers, and then add element. There's a layer collision mask. Now go to tile set, select property, and then click on this physics layer. And now we'll be able to paint the collision boxes for it. Now keep painting until everywhere turns blue. Oh, I love painting. I love painting collision boxes. It's so fun. I just can't comprehend how fun it is. And now, if we run this, the player can actually collide. With it. But what's annoying is that the enemy can go off screen and then just come back. We want it so that if the enemy is off screen, then it won't be able to do anything. So normally, if the enemy is off screen, it can come back. We want it so that if the enemy is off screen, it won't be able to do anything. Because if we don't do this, then the enemy will make us lose all of our health when we least expect it. So the enemy scene add a visible on screen enabler 2D. Which if this purple box goes out of the screen, then the enemy, it won't be able to do anything. So we want it so I'm going to make it to be so I'm going to add one here. I'm going to put it here. Wait, no, I'm going to put it here. Now you see that if the enemy goes off screen, it won't. You see that when the enemy goes off screen, it's like the enemy disappeared. The enemy just disappears like that. Sadly. So anyways, but if I no. What we wanted so that the camera will be able to follow the player. So go into the player scene or camera 2D. And any child will follow the parent wherever it's going. So the child will follow the parent wherever it's going. Now the camera is going to follow our player. Why enemy? That's what you get for being an enemy. Enemies deserve that. So you see that when the enemy goes off screen here, it's just fine. But if it goes off screen here, then the enemy basically gets stuck. So I'm going to put this in the middle. So I'm going to. So what I could do with that. So what I could do is that I'm going to put this in the middle. And if I put this in the middle, you see that, and this happens. Oh, the enemy just dies. anyways, this so anyways, now let me remove this for now. Remove. Bop. So anyways, now we have to add collectibles to our game. Now open up your image editor and create a sprite for the collectibles. The sprite for my collection is just going to be a circle, a yellow circle. Create the sprite for the collectibles, a yellow circle. Also going to give it outline. And then I go to once you've done creating the sprite for the collectible, export it inside of this folder, coin. So now this coin.png is here. Create a new scene. New scene. Make its character body 2D and name it coin. I'm going to put the rotation point here. And now drag the coin image into here. No. The coin. And now make it smaller. Cut and shift. Make it small. Put the zoom in a lot. Small. And then add a collision shape to it. Collision shape 2D. Use circle shapes. This coin is kind of like a circle. And now I'm going to add 3 of these coin scenes into here. Now this is 1 coin, 2 coins, and then 3 coins. Now you see that we have coins. Why is the coin moving? Oh yeah, I made the coin to be the child of the enemy. Remove the collision shape to the create an area 2D and put the collision shape 2D into it. Now if we do that, then the coin, it won't be able to interact with anything normally. So if it interacts with anything, we will always have to define how it interacts with it. Let me also make this smaller so that the player won't be able to just touch it and it dies. It's kind of uncool. But we want it so that if we touch these coins, then we'll be able to collect them. Write a new script, create. And now we have to write area 2D area underscore enter to connect. So if the name of the area that touched this area, if the name of it is player, if name equals player, if it is the player area, then it's going to disappear. Now you see that we can collect these coins. Yes, we can collect them, but we want the coin to be moving up and down. Func underscore physics process delta. Move up and down. No, we can set the position of the sig position.x, position the x-axis, sin, and then I'm going to create a variable called t, var t equals 0, t plus plus, with t plus equals 1, sine t times 0.2. Now you see that the codes they're doing something. I'm going to write plus equals sine t times 0.2. Now you see that the coins they're moving left and right. No, I don't want them to move left and right. Position.y plus equals sine t times 0.2 times 2. Now you see that these coins they're moving up and down like a real collectible should do. Come on, coin. But currently there's no satisfaction in collecting the coin. If we collect the coin, then it just disappears. That's it. So others the players create a label. This label is basically just text. Text. Put the label here. Now that we have this label, we have to make the label to actually display something. Save. So in this coin, I'm going to create a variable called c equal to 0, and then if this happens, that c is going to increase by 1. So now, every time the player collects a coin, we can print c in the console by writing print c. To run. So now, if we collect it, then we're going to be printed the console. I'm going to put this inside the player var c equals 0. I'm going to cut this and remove this. Enemy.gd, player.gd, I mean. So now, go to the player, click on this player area and click on area underscore entered. So if the name of the area that the player entered is, if it an area.name equals coin, let's say 6, that's the name. No, today it's coin. If the name is coin, then c is going to increase by 1. C plus equals 1. We're going to print c to the console to see if anything is actually happening. Print c. Play. Oh, what's happening? What happened to our player? Oh, an error. You have to write equals, not equals. I thought our player was the thing, man, yeah. Now we can increase it, and then it increases, as you can see here. And now, we want it so that this label 2D, it will be able to display it. So write $label dot text is equal to C. strc. Now you see that when we collect this, then the label up there, it is going to increase. What strc does is that it converts C into a string, since we cannot use labels with numbers. That's just impossible. Now we can decrease, we're going to increase the font size to like 40 pixels. Reload. No, I'm going to run this. There we go. Now it's sizable enough. You could also change the font color. You could also change the font color of the label. You could change the font color by changing this, and you could also give it an outline, which I am going to do since I'm a Habib, and Habib likes giving fonts outline, and because it is good and whatever. No, it's barely even visible, so I have to increase the size again. 10. And then no. 20. Now you see it has a sizable outline. Jump. Where's the enemy? Now we have created everything we need for our platformer game. It's time to create an actual level. I'm going to use this tile map. I'm going to select all these squares and delete them. I'm going to create an actual level with this. Then this place contains a bunch of collectibles. Coin. Oh no. It's a coin. Yeah, this place contains a bunch of coin. It's like a place full of coins. And you can also write text for the label by going to here, label, and then writing text here. Also, if you want to set the labels, color, font, outline, shadow, or anything, go to label settings and then click on new label settings and you'll be able to do that. Now, I'm going to create a bunch of labels, which basically teaches the player how to play it. Label. What is this? I don't really know. I'm going to write move with the left and the right arrow keys, and I'm going to add new label settings and include the font size. Move is the left and right arrow keys, and then I'm going to duplicate this label and to change this to jump using space. No, I meant press space to jump. Press space to jump. Press space to jump. Press space to jump. And then press the left and right arrow keys to move. Let me reduce the font size of this. No. And press space to jump. Jump on enemies. Jump on enemies. And then lastly, the last of all, collectibles. make a plate. Press the left and right arrow keys to move. Press space to jump on enemies. No, there's no way for me of getting up there. I'm going to have to edit the level, sadly. I have to edit the level to make it actually to be playable. Now, jump on enemies. I'm going to put it here. There we go. Now I've created a basic tutorial level. Press the left and right arrow keys to move. Press space to jump on enemies. Then collect collectibles. Now we also want it so that when you drop on enemies, it is also going to give you points. Let's go to if that area.tab equals coin or area.name equals enemy equals enemy. That's going to do it. Now I can press right arrow keys to move, press space to jump. Yes, now I can collect collectibles. Yay. So anyways, that is it for today's video. Hope you enjoyed it. Subscribe to my channel, ObaCode. Bye.